20 degrees over cosine 20 degrees. Just wait, Professor. 20 degrees was not mentioned in what we did for the break. You mentioned 30, 45, and 60, and some others, but you didn't mention 20. Does everyone see the answer?
Yes.
Yeah, what is it? It's 0. You know, I didn't have 20 as one of my angles to work with. This right here from one of the basic trig identity, fundamental identities, this says this is equivalent to tangent, sine over cosine. So absolutely, so if you take tan, that first term, subtract that, of course, it will cancel out, and the answer is 0. I was afraid maybe you would zoom in on, focus on that 20 and worry about that 20, forget about the identity. And there's another one here I'd like to look at. Good. Let's read this. Yes, yes. Part B. Given this, tangent theta has a value of 3. Given to me. They want us to find this tan theta plus tan of theta plus pi plus tangent of theta plus 2 pi. If we can.
We might let you be something.
I mean, we could, but I don't think I even need a U here. This is something we're thinking about based on what we did before the break. And I know it looks crazy, but it's much easier than it looks. Guys, I know this much is 3. They gave that to me. That's a 3. Now I need to somehow, in my mind, calculate what on earth do they want here. Now they're asking to find tan of theta plus pi. And then on the end, theta plus 2 pi. And then add that to my 3 and get an answer. Who has an idea?
3 plus 5.
Let me get.
3 plus 5.
No. Tangent at pi, and pi has, for the quarter pair, what over there? -1, 0, so tangent is 0 at pi, you're telling me. That's, I agree with that. Something else. Come again. Okay, well, what would you get for the final answer when you add them all up? What do you, Alina, what do you tell me for the final answer? Because I heard what you said. It's a little different. I think you're supposed to, but I want to hear it though. Guys, this one right here, you say, wait, Professor, what on earth? Look at this now. This one says in illustration, you will take theta and add pi to it. So guys, tangent theta is equal to 3. By the way, is tangent, which is y over x, is tangent, they didn't tell me which quadrant I'm in. Can I assume I'm in quadrant 1? Is tangent, which is y over x, is tangent itself positive in quadrant 1? You place a y with the x for any angle in quadrant 1, or the x and the y go to positive. So positive over positive will give me a positive, so I'm going to assume I'm in quadrant 1. They didn't give it to me, but just for a reference, we're in quadrant 1. So my angle they're talking about is over here. It's in quadrant 1. They did not read the size. Now they're asking me here to move it, how much? Pi. So that says move it pi. Does anyone have an idea? Let me throw a number at you. If this were 30, and you would move it 180 pi, you're adding 180 to it, that takes you to what? 210. Isn't it? 30 plus 180? And where is 210 located? Which quadrant? Third. If they gave me 20 degrees, another example, and you add 180 to it, you're moving it. Now 20 plus 180, what's that, 200? am I still over in quadrant 3? So does this right here represent something over in quadrant 3? If I move 180, am I now, this marker I thought would be better. Am I over in quadrant 3? Is it true? Now they're asking for tangent. Tangent's still y over x. Now if I'm in quadrant 3, guys, we determined that if I'm in quadrant 3 on a sheet of graphing paper, a grid, are both the coordinates negative. If I place a negative over a negative, do I still get a positive? Okay, so I got a positive here, because we're assuming in quadrant 1. I moved it into quadrant 3, remains positive, negative over negative. This over here was positive over positive, still positive. Now they're saying now move it 2 pi. For the last one. What's going to happen, does anyone know what may happen is, I'm trying this blue, if I go back and move this 2 pi, does that take me right back to where I started? Right here. Will that take me right back if I move 2 pi? Yes or no? And I'm right back in quadrant 1, and does that tangent stay positive? So now, with that little reasoning, can anyone tell me, they give me tan has a value of 3. Can you tell me, I was here, I got here, then I moved all the way back to where I started, what might the answer be? Yes?
Wouldn't you go 2 pi from quadrant 3?
Rather saying theta, so I placed theta in quadrant 1. So I went back to quadrant 1 where the original theta was located. What do you think the answer is? I just saw this and I thought, I gotta show my students before I move on. What do you think the final answer is here? If you take this, add to it whatever this is, we don't have a value yet, and this, what do you think the final grand total will be? Simple answer. 9. Will this be 3 again? Is it going to be the same number? Thank goodness it's positive again, right? We started out with a positive over a positive for tangent, that's positive. This retains that positive, thank goodness. In fact, it's going to be positive, that same number they gave me, 3. And then it said, make this one happen now, move 2 pi, which takes me right back to where I started. And definitely that's another 3 there. So if I add all these up, is the grand total 9? What would have messed me up? Thank goodness it didn't. What would have messed me up would be if I had, or if they had said move, and I had landed in quadrant 2. And I'm doing tangent, which is y over x. Guys, if you're in quadrant 2, I think the coordinates are a negative and a positive, and you place y over x there, place a positive over a negative, that's y over x. That result will be what? Negative. That would throw me off here. I couldn't do what I just did. Thank goodness all these were positive. 3, 3, 3. And add them up, you got 9. I thought I'd just point that out before we get started here. Thinking about what trig is all about here. Did I do something else? I did, and this is going to close this down here, guys. Given, let's see, this information. We do work hard here. Secant theta is equal to 2. This is more in line with what we were doing before the break. And sine theta is less than 0. Find the exact value, no calculator in other than the remaining trig functions. And I'll just list what's remaining, as much like what we were doing before the break, which I think we need to do before I jump into something new here. Guys, missing here is sine. Gotta find it. Cosine is missing. Tangent's missing. Cosecant is missing. And looks like cotangent, I don't think I listed it yet, missing. I gotta find the values for those 5. They gave me secant. And I know by definition what secant is. I think I know what secant is. What is secant? Wrong one. 1 over x. Is it 1 over x, guys, for secant? Don't confuse secant with cosecant. Is it true? Okay. And they are trying to tell me where my angle is located, because I need the quadrant. But they did not come right out and say you're in quadrant 2, you're in quadrant 3, you're in quadrant 1. They're trying to tell me though in that given where I am, because that's gonna play a part. Guys, they're saying secant is 1 over x, and it's a positive 2. Can anyone tell me of the 4 quadrants, just for that part there? Where is secant 1 over x guaranteed to be positive? Which of the 4 quadrants? First, everything's positive in 1, absolutely. And for secant to be 1 over x also positive, there's another quadrant, not second. 4. So this says I'm either in this or this. This way, Professor, I thought you were supposed to be just in 1, but we're not quite finished. They added to it. Also, sign must be negative. Sign is less than 0, must be negative, and I know the definition for sign. Sign is y. So guys, can anyone tell me, and I'll place those right at the top there. Can anyone tell me where is sign y negative of the 4 quadrants?
3 and 4.
3 and 4, that's what I want to hear. Do they match up in quadrant 4? That's where the angle is. I'm in quadrant 4. And I'm not going to try to name the angle, the size, I know the location, I'm in quadrant 4, based on what you see up here. So guys, quadrant 4, let me list right quickly, since I am there. From algebra, if you're down in quadrant 4, you're guaranteed the coordinates should be what for a point down there? In quadrant 4. Positive and what? Negative. Which is going to play a part. Now let's try to find the answers. So now I know I'm in quadrant 4, and that's positive, negative, which will play a part. Before I jump in and try this, some students were wondering, probably wondering when I ask you which quadrant are you in, which quadrant are you in, Professor, what do you mean here? Let me do something real quickly. On the side here. Let me just mention which functions, trig functions are positive. If you know where they're positive, the others are negative, okay? Quadrant 1, sine, cosine, tangent, secant, cosecant, cotangent. If you're in quadrant 1, what value of a sine are you guaranteed for all 6 if you're in quadrant 1? Positive. Are they all positive? Are all 6 trig functions positive if you're in quadrant 1? Because you have a positive and a positive to work with. Is that true? So they're all positive. I'm talking about just the positives right now. Now if I move over to quadrant 2, be careful here. You know from algebra we're talking about this. Aren't we?
Yeah.
Now be careful. Based on a point that's negative, positive for quadrants. For quadrant 2, negative, positive. Which of the trig functions, be careful this time, are guaranteed to be positive there? Sine, because sine is y, and y is positive, for sine. And there might be one more. I heard, not secant, cosecant. Let me just abbreviate. Sine is the y, and the y sure enough is positive from algebra in quadrant 2. And then cosecant is what? 1 over y, that will remain positive. And I think the other 4 are negative. Now let's go down to quadrant 3. If you're in quadrant 3 from algebra, I know this. They're both negative. Now which of the 6 would give me a positive down in quadrant 3, knowing that the coordinates are negative, negative? Thank you. I'll just abbreviate. And tangent works also should work. Cotangent. So since I'm in quadrant 3 there, is there anything else besides tan and cotan? Are those the only 2 of the 6 that are guaranteed to be positive? If I move over to quadrant 4 from algebra, I know and you know the coordinates are those? Now, which of these six are positive based on those coordinates?
Cosine.
Cosine,
And secant.
thank you, that's exactly what I wanna hear. Exactly what I wanna hear. And those are the ones that are positive, therefore that means the others are negative in those quadrants. Now, the way I remember it, sometimes I'll forget which are positive, and then of course I know which ones are positive, I don't know which ones are negative. The way I remember it is these initials, A for all here, S here, T here, initials here, and C here. Sort of helps me remember, if I should tell you just a few seconds what I like those initials to represent, to sort of help me locate. This is all. S for students, T for take, and C for calculus. So all students take calculus, sort of helps me to remember which ones are positive in which quadrants. But the little initials, all students take calculus, just a little thing they remember which is which. Okay. Guys, that may help us. Now let's finish this up and then we're gonna get a few graphs here done. This is something like we were doing before the break, which is critical. Oh boy. I got secant to be a positive 2. We've already determined that we're in quadrant 4. Now, of the 1, 2, 3, 4, 5 that are missing, and you have to validate. Can anyone tell me, based on what they gave me, which of those 5, and I don't care which one you find first, it's up to you, but you gotta validate it. Does anyone see, I see one that's really, really easy to get. Which one is it? I would think, hang on now, cosine must have a value of, tell me what it is. 1/2. Now why'd you say cosine real quickly based on what they gave you? What's my identity that I need? I think it's written as what, secant? Is equal to what? 1 over cosine, in other words, they are reciprocals, and that's the way it's written, and that would validate that reasoning. They are reciprocals. Now I've got 4 more missing. Oh, by the way, I'm in quadrant 4, and that's going to have to be a positive 1/2, and it should be. Does anyone have an idea? Another one, and then you gotta give me the identity, Alina?
Tangent?
Tangent?
Yeah.
Okay, hang on now. So tangent, hang on, and the identity that you're gonna use more than likely, Alina, is tangents equal to what?
It's,
Was it sine over cosine?
yeah.
Sine over cosine. Now, if I look at it and I want tangent, I don't know what sine is. I know what cosine is. Do I have sine yet? I may have to hold off on that. Maybe she had another one in mind.
We can find this secant plus square minus 1.
Okay, hang on. Secant, right here.
Yeah.
Okay, which of the 6? Name it for me again. I think I heard you say it.
Secant square minus 1 would be.
Okay. How was it listed out in the identity? Did I say like 1 plus tan squared was equal to secant squared? Is that the one you're thinking of, or not? I think I heard the same thing. Just hang on, I got it. Hang on. Right now, I can't use this one. I don't have enough to work with. I don't think. Hold on.
It's 1 plus.
1 plus tan squared equals.
secant.
Love it. Love it. 100%. That's exactly one that you could use. Now, what can I do here with what she gave me? I got 1 plus tan squared. Thank you. That's exactly what we needed. And secant squared, they gave me secant. Secant is 2, so it's 2 squared. Now let's do the work down here, guys. So you're going to end up with tan squared. When you solve this, that's a 4. 4 subtract 1 gives me a 3. Take a square root, and at this moment it's plus minus radical 3 at this moment. Alina, thank you. Now I'm in quadrant 4, I gotta be careful. If I'm in quadrant 4 and I'm doing a tangent, which I think I am doing, tangent is y over x. If If I'm in quadrant 4, that means you're placing a what? A negative over a positive, that gives me a what? Negative. So it says, Professor, the answer to accept is negative. So this is a negative with her help, square root 3. Nice. Elena, when you said that, I've taught this many times, many students do not see this one real quickly, and you did. 1 plus tan squared is equal to secant squared. Nice. Now, what else do we have? And got to validate. What else would you like to find? I've got sine missing, I've got cosecant missing, I've got cotangent missing.
We can find signs.
Okay, now you've got to validate which of the basic fundamental identities are you going to use? You got to validate for it.
1 minus cosine squared.
There you go. I'm writing like this. Two TAs are probably sitting back there thinking, oh my Lord, the responses for this class. Is that right? Sine squared plus cosine squared is equal to 1. You're thinking the same thing here. And the cosine we found earlier to be 1/2. So I can put that 1/2 in there. Here goes, guys. Squeeze it in. That's 1/2. 3n squared equals 1. Run out of space here. So this becomes sine squared. It looks like this is 1/4. When you move it over 1, subtract 1/4. Was it 3/4? And into a square root. At this moment, it's plus minus. Radical 3 over 2. Let me step back and look at it. And see if you guys will agree. Is that good? Okay. Now, is it plus or is it minus? Well, it all depends on that quadrant up there. And we're trying to find sine. Was it positive or negative? Negative. So it's a negative for radical 3 over 2. You guys have followed this extremely well. Nice. Now we got 2 missing.
We can find cotangent.
How you gonna find it?
So, reverse tangent.
Well, name it like we had it written before the break.
Cosine divided by sine.
There you go. There you go. You can use that. I bet somebody should break off something else to use to find something. You could. Cosine over sine should work. Cosine was 1/2. We found that earlier. Sine was given, no, sine was given 2. Sine was negative radical 3 over 2. That we found earlier. That's cosine over sine. 2's cancel. Give me a negative answer. And you got 1 over radical 3 simplified.
Just radical 3 divided by 3.
Absolutely. Thank you. That's cotangent. We'll put it right here. Out of the way. Wow. Only 1 left, cosecant.
1 divided by sine.
1 over sine. Guys, we'll put it over here since I'm out of space. So cosecant is equivalent to 1 over sine, which merely says they are reciprocals. So if you go up to sine right here, flip it over. I know it's gonna look strange. It's gonna look like this. Negative what? 2 over radical 3. Rationalize that. That's a negative 2 radical 3 over what? 3. And we're all done. Now, did they ask me? And I better not ask it this way. Did they ask me what angle is theta? Is theta 42 degrees? Is it 100 degrees? They didn't ask. And we didn't have to do it in order to answer these. I could ask Mr. Parker to look with theta and find the size and approximate and see if we're close to what it should be. Guys, any concerns? Yeah.
60.
Oh, you're saying 60. Here we go. Oh, look.
No.
Hang on.
It's 300.
Okay, I'm supposed to be in which quadrant? Quadrant 4. Oh, you said 300.
Yes.
Oh, look at this. Look at this. My goodness, Mr. Park, go down the hall and tell the other professors to come in here. Say, anything thinks it's 300 degrees. That's what we're talking about here. Do me a favor, Mr. Park, have that calculator in degrees. Find cosine of 300. This cosine, so every cosine in degrees, 300. I'm gonna do a little check here.
1/2.
How much?
1/2.
1/2.5. Check's there. Hang on now. Wow. Let's check one of these straight ones. See if this guy's correct here. Find, this is pretty straight here. Find sine of, he thinks it's 300. Find sine of 300 for me. See what that calculator shows.
It's the same. -√3/2.
Negative root, it's the same.
Yeah.
Oh. Since you have the calculator, can you find cosecant for me? 300. We got this strange thing.
-2√3/3.
A -2√3/3? He's correct. The angle is 300 degrees. I heard him first say 60. I tell the class why, because you probably recognized something from before the break. You said 60 at first, so you sort of recognized it. But then you changed to 300 for what reason?
Well, because 60 is equal to 1.
Yes, and we're supposed to be in which quadrant?
Well, no, 4.
Oh. And therefore, he says if you're in quadrant 4 with a 60-degree reference angle, you're talking about 300 degrees. And it works. Now, I'm not going to ask you to tell the number of degrees, no. I just want these numbers, these values, and a validation. That's all I want. Okay, guys, I see my time. You know how fast time moves in here. Part 2, let's call it. Here we go. I will have time, just enough time, to get you started on what do some of these trig functions look like when you sketch them. Now, you gotta keep in mind, I've got 6 of them. You have 6 of them. Hang on. Let me see if I did it for you. I hope I did. Oh, I did. In fact, I think I showed you guys this. You'll see what all 6 should look like, and some information about all 6. One side's in radians, the other side's in degrees. I'll get this to you. But we're gonna graph a few of these. Now, am I gonna graph all 6? No. We're gonna be here forever. We'll graph maybe sine and cosine and tangent for sure. And then one of the others. Not today, though. We will eventually sketch these 4 of them. Guys, I'd like to start out with this function. I'd like to know what on earth does that function look like sketched? It's sine x. All I know about right now, the definition is y. The definition is y. I'm going to do this. Well, first, I think you will like this. I'm going to reflect back to, real quickly, the unit circle, which I'll place on there here, on there soon. And make it look as nice as I can here. And we'll get the graph of sine, which some students may recognize already. I'm gonna see where it came from. Guys, let's go back to the unit circle. Quick reflection. Let's say it looks something like this. And let me point out a few things we know about this unit circle at this point. This represents 0 degrees, or 0 radians, and the ordered pair is 1, 0. This point represents 90 degrees. I would prefer pi over 2. Ordered pair, 0, 1. Unit circle. This one was pi, 180 degrees, and had coordinates of those. This down here, of course, was 3 pi over 2, 270 degrees. And the ordered pair was that. You say, Professor, are you gonna put 30 and 60 and 45 on there again for us? No, I just need those basic ones. What's gonna happen? Just need the basic ones. I think everyone in the class would agree with that so far. Now, what I want to do is, I like to call it unwrapping. I like to unwrap this unit circle. What am I gonna do? I'm gonna take it and now put it over here in a special way. First, I'm gonna label my x-axis with my angles. 0, pi over 2, pi, 3 pi over 2, and of course this would represent 2 pi if you go back to the beginning. You guys do 0 here, pi over 2, pi, 3 pi over 2, and we'll go out to 2 pi to make one complete revolution. Replace 2 pi here. Those are placed along the x-axis taken directly from the unit circle. Now, I'd like to place, if I can, on the y-axis, what looks like the highest I go is up to 1. And I see a -1 on some of these, so I drop down to a -1. So on the y-axis, I'm going to say 1's right there, -1's right here. And that's basically the numbers from the unit circle. Now, what would I like to do, let me see if this marker will work for me, guys. Here goes. We're doing sine. Sine is y. Let's go through this unit circle and look at the y's, just the y coordinates. My first y coordinate is 0. That means at 0, we want to start. Of course, not a good marker. Doesn't work. Let's try this one. You guys can see it. At 0, we're going to start right here. Oh, much better. At 0. At pi over 2, when I move up to pi over 2, I'm looking at the y only. Sine is 1. So it says at pi over 2, I'm up here. At pi over here, looking at the y coordinate only, the sine, that's 0. At 3 pi over 2, I'm down here, the y coordinate is -1. I got to plot -1 at 3 pi over 2. Let's say it's right in there. 2 pi takes me back to where I started, so I'm back at 0 for y coordinate. You guys agree? Did I plot those correctly? Now, when I connect them, now notice when I scored those papers last night, and I asked you to do a graph, some students try to draw a curve with straight lines. In other words, I saw some students doing this. The graph should have been curved like that. They went like this. I didn't take any points off. But no, if it's supposed to be a curve, you gotta put a curve to it, not straight lines here. Okay? Here, it should be a curve. Now, how it's going to work, left to right, this means it's going to go up, there, come down, pick this point up, we'll come down to here, I'll put down here, like that, like that, and make it look something like that. And then we're going to call that one cycle of the sine graph. That's the way sine looks. That's a picture of sine. Now let me ask you this, before I leave it. Could I, if I wish, could I, after I stopped here, could I now pick up and do another revolution if I wish? Yes. So this thing continues on the right. And how many revolutions could I do if I had the time? Infinite. Is that true? Also, could I please, some students will do this, could I on the graph here, maybe move to the left? In other words, you could start here, Professor, but maybe go backwards this time on the unit circle. So it's also going to go on the left and the right forever. So I just have one piece of the graph, the major piece of the graph. But you could do this, and I'll just do it right quickly, guys, right here in the blue. You could continue and draw another cycle. And you could pick up with that and draw another one, and another one, and another one. If you wish to start here and then drop down, you could say, Professor, does it continue like this? It could be like this. And that goes forever. Okay, so it's infinite on both ends there. That's my sine function. We're mostly interested in what you see there in the pink or the red. That's called like a parent graph. That's what I'll be using for my parent graph when we start sketching some of these. Guys, are we okay on this? Okay, let's get this out of the way then. Some characteristics of this strange looking graph, like a wave of some sort. The sine graph, what it looks like to be a wave. There's some vocabulary. First, if I ask you for the domain on the entire function, I know I just had that one cycle drawn for you in the pink. What would you say the domain is if you include the entire function? Infinite, negative infinity through positive infinity. Follow. Now the range is the up and down.
From -1 to 1.
Yeah, so it drops down to a -1 no matter what cycle you're looking at, up to a what, +1? So the range is -1 up to a +1. Pretty obvious. Some other vocabulary I noticed that your textbook gives is asks students sometimes to identify the amplitude of the graph. That's the highest the point goes up to from its axis. Well, its axis is the x-axis. What's the highest point it goes up to?
1.
1. That's the amplitude described for sine. Now the one that we're going to really work with, maybe not today, the period of the graph. Does, and I think you guys agreed with me earlier, does that cycle repeat if I wish it to repeat?
Yes.
Now, how far out did I go before it might start repeating? Does it start repeating here at 2 pi? So the period number for sine will be identified as period of 2 pi. So every 2 pi movement you make is going to repeat whatever that value was that you were working with. So we got period, amplitude, we got the one cycle I want you guys to look at. Looks good. And that's the way the basic graph looks. I'm watching my time here. That's the way sine looks. That's this picture, right there. Can anyone tell me, I've got some clever students in here. Can anyone tell me, here we go. Where is this pink graph? When is this pink graph? Like this. When is this possible? Based on your graph.
Every 5.
Come again.
Every 5. Every 1 5.
No. Easier than that. Remember when I asked you to graph, a few graphs for me on some other items, and I asked you where is f of x less than 0? Where is f of x greater than 0? What are you looking for? You're looking for when is it above the x-axis? When is it above the x-axis? Between 0 and what? Pi. Above, like this, guys. Is that true? Now, please help me out. If you say from 0 to pi, you're saying, Professor, here's 0, and here's pi. Which two quadrants are you talking about? If I go from 0 out here to pi, am I covering quadrants 1 and 2? If I go that direction. So you're saying quadrant 1, quadrant 2, Professor, you're guaranteed that sine is positive. And I know sine is what? Y? Is the y coordinate sure enough positive in these two quadrants? So sine is positive, and the graph shows me. Now, when is this true? When is my function sine less than 0? Okay, right, and on my graph, it's caught between what? Pi and 2 pi. Which covers, here's pi, here's 2 pi. Am I going from quadrant 3 into quadrant 4? So I move from pi to 2 pi. So it says quadrant 3, quadrant 4, and for a little check here, I know, you know from algebra, this is what? Negative, negative, remind you, before I leave this. And this was positive, negative. And we're looking at sine, which is a y coordinate. Is the y coordinate sure enough, sine sure enough, negative in both those quadrants? And that's what my graph shows. It should be below the x-axis there, and it is below. Okay? Now, we're out of time here. Gotta be careful. At least we got to this point. Oh, boy. Now, I told you the story about the middle school kid who took my class. I told you the story. Remember that story? I'd love to know where that kid is now. I'd love to know where he is. Maybe he turned into Elon Musk, who knows. But anyway, he sort of missed on the final exam. Didn't miss anything. He just did it a little differently. I asked on my final exam, I now recall now since I see this graph. I asked on the final exam, please draw me one cycle of this graph. Not this particular one was a hard one. Now remember what he did. Who would do this? If I say right now at this point, draw me one cycle of the sine graph, my students would say, Professor, it's that pink graph. No. He went down there, there. I think it was down to the 15th or 16th cycle. He drew one way down there. And I thought for sure, he finally missed something. He had all those perfect scores. I told you guys the story about him. I thought he finally missed something. I'm gonna take a point off. He didn't get a perfect on the final. And then I thought, oh, hold on. I gotta look at my directions. I said, draw one cycle. He chose to draw that cycle way down there. And he had it labeled perfectly down there. He didn't draw this where you and I would draw. No, he went way down there. Drew one. But they do repeat. Why he went down there, I don't know. But it was labeled correctly and he full credit. He drew one cycle of the graph. Guys, that's making sense. I think it's making sense. Put all this together. Chapter 5's almost done. Basically done. Any concerns here at this point? I think we've done a good job. And the connections here. Thank you, students. Like this, the student gave me some responses today. They led me to some things that I was not going to do today, and I thought, I've got to do it since my student brought my attention to it. And then a student gave me the size of an angle. She's sitting there looking and said, Professor, that's 300 degrees. Guess what? You have no calculator. Where'd you get that? It's 300 degrees, Professor. And we checked it. It was 300 degrees. My TAs and myself, we're blessed. We are blessed. Now, how many trig functions are remaining? I just did sine. How many are remaining? 5 more. Good luck. I'm not going to graph some more. Of course, I'll graph some more. I haven't graphed cosine, nor have I graphed tangent. And secant and cosecant I'll probably do, and cotangent. I'll probably do one of those, maybe the other two for you guys to look at, see what the shape might look like. Guys, when we step to the side here, I don't think I'm going to have time. Oh my goodness, I don't think I'm going to have time to do this. Hang on. Let me ask you this, since this is a clever, creative class, it's just something on the side, and we'll talk about that test tomorrow. Suppose you're asked to find this. Let's say you're sitting there taking a final exam, and you're asked to find this. Log base 2 of this. So on your final exam, I get to bring everything together. There's a log with a trig. Now I heard the answer was -1. Arena, class, this from trig, sine of 5 or 6, sine of 30 degrees, I think that's 1/2, isn't it? Ask me here to find log base 2 of 1/2. She says, Professor, it's -1. Arena, tell the class why.
Because 1/2 is 2 in the power of -1.
2 raised to a -1.
And we're taking that -1 and putting it in front of the logarithm, and it's gonna be logarithm base 2 over 2.
Okay, it basically does come down to you doing this, which I think I heard you say. 2 raised to a -1 is 1/2. Is 2 raised to a -1 1/2?
Yeah.
There you go, that's the answer. Okay, there's a log with a trig. And then by By the time the final comes up, I can do this even on this. Why not? And then maybe do this afterwards. I see what it looks like, oh, that's don't go crazy. Don't go crazy, just put a square root and an absolute value, what are you gonna do next on that? Don't go crazy on it. Okay, guys, let me slow down. Now, my concern right now, I was gonna give you the handout on the grass, I'll hold off on that tomorrow. My, part of the class tomorrow, I usually take about an hour, but we have 3 hours, I usually take approximately an hour to do what I gotta do, so I won't get behind, then I start the test, right? We're gonna try that, and this is gonna be a demanding test. Now, you guys have seen the, review for the test. Please, please, please look at that review. Please, please, please be with me tomorrow at 11:30. June, Mr. Park, are you guys available at all? Tomorrow's Friday. Park?
I'll be at the morning, Alpha, before your.
Before I do mine, you're gonna be in the
Yeah.
math lab?
Yeah.
Okay, so guys, he's gonna be in the math lab, to work with, he's gonna stop by and ask a few questions.
When does your session start?
11:30.
I'll be at 10.
Oh, okay.
Yeah.
So he'll be in the math lab at 10, and I'll be here at 11:30, okay? Get ready for this knock-out test. Now, I need your help. You did a beautiful job here in class. Just get on the side here. I need your help. Tell me what might you think right at this moment might be, in terms of topics, might be on the exam tomorrow. Just tell me something, I'll jot it down with you. Tell me again? You have a polynomial function. Now, I don't have your quizzes to return to you yet. Just wait, Professor, we had a quiz last night, and you gave me a really nice one, and I got it right, I got a 10 out of 10 on this quiz that we took last night, right? Well, you want to see another polynomial function. Now, I may not ask you to sketch it, I'll probably ask you to sketch it, but along with sketching it, you'll probably be asked to find what? The zeros. You may have to show me Descartes' rule. I didn't ask you to show me Descartes' rule last night. But it'll probably be typed on there, show this time. You gotta show me Descartes' rule, and finding those zeros. You gotta show me, just the setup for rational zeros theorem. You may even, or I may give a hint, that there's some way you could use this that we talked about. Intermediate, what was it, value property? I know you guys are a little tired here after all this today, but can anyone recall what that intermediate value property tells us, which might be beneficial in certain cases? Joseph, go for it.
And certain values see that in between the two x values that equal 0.
Okay, so he says, Professor, in your testing, if you go through synthetic, and it does not work, you don't get the zero on the end that you were wishing. But I noticed you tested, Professor. I went over here, Professor, I was hoping for a 0, but I got a -3. I got disgusted, I had to go back and test something else. And you test another possibility, and this time you end up with, let's say, maybe a 1. It didn't work. Do they change sign? So if they change signs here, the intermediate value property says there is an answer, at least one answer, could be more, caught between these two. So you may want to go back to your set of test numbers and try one caught between these two because of the sign change. Okay. If you do not have a sign change, you do not have one. If they change signs, intermediate value property says go back and try one caught between. And try it, see if it'll work. There should be one there. Okay, that should help. We'll get that out of the way. That's polynomial function. Tell me something else, guys, before we run out of time here, that you might witness, see, which I'm scared of myself. Uh-huh. Oh, I'm scared of this one. We might put some study time in on this. A rational function. That's the type where you find the vertical asymptotes, horizontal if there is one, oblique, you find that oblique asymptote, intercepts, in behavior intercepts, asymptotes, they may cross the horizontal asymptote. I think we had one in class that did cross. So you gotta look at all that. Jim.
Can it cross the reduction function, cross the oblique
And look at that, it could, I didn't mention it, it could. But I'm gonna make sure this one does not. Okay, it could cross. So guys, rational function, ooh, get ready for that. Because that one right there is probably gonna take one page. We've got tons of questions to ask after you graph rational function. Tell me something else, guys, that you might be worried about that says, Professor, I think it's gonna be on there. I'll help you. Oh, domain, word domain. For example, let's use a natural log. Let's see, was this in 4.1, 4.2? I think 4.2 had, did I have domains on my review? Yeah, 4.1, 4.2, I think it was. ln of this. ln of 1 minus x squared, and you'll find the domain of it. How does one approach it? What do you know about a log that helps you find the domain? This inside part must be what? It's gotta be that. And this would factor. And by this point, I think all students would recognize after factors, you're going to use what? Sign analysis to answer that question. The true? And that'll help you answer the question. Okay, that's domain, rational function, polynomial function. Randy, what else could you place on there? Would you guys like to see a copy of it? To make sure I placed everything I need? I'd like to see a copy of the test. Just to make sure I do have all the topics. Yeah, right. Anything else, guys, before we close down? Ooh, 4.1, 4.2. Was 4.2 the inverse functions? I think it was. Good luck. Inverse functions. I think all this is on that review I sent out. In other words, finding this. And the domain of the inverse should be the same as what? The range of the original. We talked about that since things are being switched. A range of the inverse should be the same as the domain of the original, if that will help you somewhere. If I'm the inverse, that's interchanging x and y. Then you've got to check it. Does anyone recall how to check it? Absolutely. Take F, do a composite. And you hope you get X. If you do not get X, you messed up somewhere. That's where you check it. All this is in your notes, and June's notes are beautiful. You guys can go back to, she did detailed notes there on all this. Okay, now those are some of the basic topics. But I think all I did on your review, I said, make sure you're responsible for chapter 3, wasn't it? And 4.1 and 4.2. That'll be the test. Gee. Wow. Let me check. Does anyone recall how many A's I had? I reported to you guys.